Who do not know me, my name is Jake Marin. I'm the lead emerging opportunities manager for Efficiency Vermont. I've been with BEIC now for 13 years. So I've done a lot of things with heat pumps over the years, and I am particularly excited about the emergence of window heat pumps, and something I've been thinking about and working with for a couple of years now. And things are really starting to heat up. We're getting ready to launch a pilot soon, which I'll talk a little bit more about. So the timing is great here. So to kick things off, window heat pumps, an electrification solution for renters. So I guess just really the first question before we kind of dive too deeply into this is really why we want to even think about something like window heat pumps. Don't we have a million other kinds of heat pumps? Why do we need something new? So silly picture here, but the basic idea, right, is we know that one issue that we are starting to see more and more are constraints associated with electrical infrastructure in our buildings, right? I'm sure for those of you that are installers, this is something you're always have to be aware of when you're going to look at a new job, right? Looking at the panel to see what sort of panel capacity you have. So there's definitely often issues related to having to upgrade the service. In addition to the panel, sometimes that even triggers a transformer upgrade. And the cost to the consumer, to the customer, can be in the thousands to even up into the tens of thousands of dollars. And so this is really can be a big issue and can stop people, or really halt them on their path to electrification and putting in heat pumps. And the beauty of these window heat pumps is that they will plug right directly into a 15 amp, 120 volt circuit, often with no need for any electrical changes. And I'm sure that for many of you, this is something that is near and dear to your hearts, and that you see every day. But generally, in terms of the workforce, we are seeing a huge decline in HVAC techs, right, and to the tune of 50% over the last 10 years. And when we talk to what we call clean energy employers, this is from the Energy Action Network report, 92% of clean energy employers say that it is either somewhat or very difficult to hire new employees for their company, right? So this is a huge challenge. And although there's an incredible amount of really great work that's happening here with workforce development, it still continues to be a real challenge. And we have seen the heat pump growth. We were seeing massive growth in this market here in Vermont, and it has really leveled off. I'm even hearing some reports of some small declines in certain areas. There's a large, complicated answer to that, but we do know that in part that is due to everybody being really stretched thin. So the last thing I really want to call out here is that these products do seem to have the opportunity, or at least present the potential, for DIY. And even if they're not full DIY, potentially lower skilled contractors. So you don't necessarily need somebody to have an EPA 608 license to manage refrigerants, because these are fully packaged. Again, there's no refrigerants, no touching refrigerants, there's no electrical work. So this can be handled often by anyone on your staff that might not even be someone like a service tech. And then, of course, there's the refrigerant issue. And although this has been kind of a black eye for the industry, we're starting to really acknowledge the fact that eventually all systems leak, okay, to lesser or greater extent. Refrigerants in those systems are leaking out, and we do know this. And the refrigerants that we've been using, in particular 410A, right, the predominant, almost exclusive refrigerant used in heat pumps, It's a very high global warming potential, thousands of times worse than CO2 as a greenhouse gas, right? It's over 2,000 GWP, as we refer to it, global warming potential. So a pound of 410A leaking out is equivalent to over 2,000 pounds of CO2 as a greenhouse gas. And a lot of times it is those field connections that are leaking, right? There's, depending on the conditions that these are being done, whether it was a good flare or not a good flare. And it's not always field connections, but it is often. And so these kind of pressure tested, manufactured products products that are self-contained, that put together in a factory under optimal conditions, are much less likely to leak, and they also have substantially less refrigerant per capacity, right? Because there's not a big, no line sets, there's no big split between the indoor and outdoor unit. It's all contained in that one unit. Now, that said, of course, we are making the transition to lower GWP refrigerants like R32. And R32, for those of you that have been following this, is although it is about a third of the global warming potential, it does have some flammability, right? So now we have this added element of safety concerns, requires new equipment in order to handle that refrigerant. So the beauty of these, window units, it kind of bypasses all that. They do contain, a lot of these newer ones contain these A2Ls like R32, but they are all packaged, so you're not having to touch any of that refrigerant. Another issue that I wanted to raise is equity, right? So we are definitely seeing a discrepancy in who can afford to actually bring heat pumps into their buildings. And it's predominantly folks in a higher income bracket. But we're also seeing that it's also renters that are really being left behind, right? And so in Vermont, we have about 29% of all people are renting their building. And that presents a real challenge for electrification of those buildings. Who's going to pay to get that done? The landlord, who potentially has nothing to gain by paying for that equipment, or the renter, who really can't make permanent modifications to their building, and even if they could, wouldn't want to because it isn't their building. So this is a real issue for bringing along essentially a third of our population. How are we going to get heat pumps in rental buildings? And window heat pumps do present an interesting opportunity, which we'll talk more about in a moment. So there are some other benefits of window heat pumps that are worth calling out. One that I particularly like, and I think this applies to a ductless mini split as well, but there's really this modular room by room approach, right? So I think we know that customers in Vermont are not always ready to jump on a whole building solution on day one. They might want to go for, we really need something in the living space where we spend most of our time. And then, of course, it'd be nice to have some air conditioning in our bedrooms. Maybe in a couple of years, we work on that. And so the ability here to kind of add these as needed throughout the building is I think, going to be very appealing to a lot of people. And it's this whole semi-permanent installation. And when I say the word semi-permanent, what I mean is that you put this thing in and you leave it there. You don't take it out every year like you would every winter like you would your traditional window unit. But although it is sort of a permanent installation, you can take it out and bring it with you if you move. And that is not true generally, at least not easily, with the ductless mini split. And we're seeing the opportunity for people to replace their existing window AC units, which of course are known affectionately as window shakers, to these now inverter-driven, really quiet, efficient options. So I think there's really some interesting and very compelling reasons for why window heat pumps can make a lot of sense. So what are we really talking about? What is a window heat pump? So there are three different kind of, I call them form factors, different types of, looks and applications that have different applications, right? So the one on the left that you're looking at there, we like to call these wheelies or portable units, right? These things can kind of, uh, they just usually two lines, two hoses that run out through a window. You kind of have to rig up a little bit of this, the window in order to get the hose to go out. Not particularly attractive, but can be very versatile. There's the traditional cube style in the middle there, right, which is what we're used to seeing for window air conditioners. And then there's this new version that we're seeing that seems to be getting a lot of momentum that are often referred to as saddlebag on the right there, where you can see that a portion of it's essentially an upside down U, and it sort of hangs on your sill with kind of like a split system in that it's got your evaporator inside the building and it's got your condenser outside. They are connected through that bridgeway. And yeah, so this is what we're starting to see a lot of movement in this direction for a number of reasons, which we'll talk about. Looking kind of current state, if we look at window heat pumps, because this is not actually brand new, there are a lot of window heat pumps out on the market that have those various form factors that I just showed you. But if you look at what they can really do for cold climate performance, they're really not designed for that. Most of the equipment that's out there is cutting out above 45 degrees. They don't have the ability to do any kind of defrost cycle. So a lot of them will incorporate resistance heating that they just swap over to when you get below 45 or 50 degrees. And finding variable speed in this equipment is almost unheard of. In comes the Clean Heat for All Challenge. So this was in New York City, and this has really been a game changer, focused on New York City public housing. So what is this? So the Clean Heat for All Challenge was a competition that got set up by NYPA, which is the New York Public Authority, I believe, and the New York NYCHA, which is the New York City Housing Authority, along with NYSERDA, sort of paired up together and have focused on these big multifamily public housing buildings and trying to come up with an electrification solution. And so they set a whole specification of what they needed, essentially a cold climate heat pump for these buildings that could meet 100% of the needs of the building. And so this was awarded to two companies, Midea, which you may be familiar with. Midea is a large global manufacturer. They do make mini splits, central heat pumps. In fact, they white label or private label for a whole lot of manufacturers that you're probably familiar with the brands. Actually, Midea makes them. So huge company. And then you've got Gradient, which is actually a California Bay Area startup that's been working on, and they're really kind of the OG of the cold climate window heat pump. And they've been at this now for a few years and have a really, really cool product. So between the two of them, they were awarded guaranteed 30,000 unit purchase based on the performance of their prototypes. So really pretty exciting way for New York to kind of throw a whole bunch of money and give a very specific challenge to the industry. And these sort of cold climate window heat pumps are what have come out of it. And just to give you a sense of the kind of capabilities or the requirements that the challenge set in place. So obviously these are window units they need to go in windows. The requirement was that no electrical system upgrades would be needed, that there was really no specialized installation. So any kind of handy person should be able to install these things within a couple hours. And as I mentioned, they go into a conventional 15 amp dedicated circuit. The units at this point are all only 9,000 BTU. I say only, meaning there's nothing smaller, there's nothing larger. And they need to operate below 0 degrees. In fact, I believe both of the units, the Midea and Gradient units, are operating at least -13. So they are designed to be 100% of the heating for these New York City buildings. No resistance heating is allowed. I mentioned that it's a quick installation. They need to be less than $3,000 a piece, and they have to have some form of condensate management, right? So this isn't super important in Vermont, but in New York City, you can imagine, a high rise, 12 stories of these window units, all kind of going into defrost cycle and dripping down onto the sidewalk, not in creating an ice skating rink. So not a great thing. So they have to all manage that condensate internally without dripping it outside. And we can get into some explanations of how that's being done if folks are interested. Yeah, I'm speaking quickly. I'm gonna take a quick breath and a pause and see if we've got any questions about what we've gone through so far.
Thanks so much, Jake. Folks can raise their hand if you want to chat or take a second. Oh, great. Or take a second here to type something in the chat and we'll get to it. So Roland has raised their hand. Go ahead, Roland. Feel free to unmute. See, you've unmuted, but we're not hearing you. All right.
So we will have time toward the end. We should have quite a bit of time for Q&A. Roland, if you want to put a question into the chat, we'll definitely take some time to answer it.
Yeah, and we do have one question.
Okay.
If you're not going to get to this a little later on, can you elaborate on the installation process?
Yeah, I was not going to go into detail with that, but yeah, absolutely. So it's pretty interesting, actually. So the way that it works, if you picture this thing it's a U, right? It fits down over the window this way. So the first step in the process is to there's a bracket, a specialized bracket that fits into your window opening. And then that bracket actually has a flat platform. It's more of like a U shape than an L shape than it is like a U. It's flat out like this to the outside. And what ends up happening is that both Gradient and Midea have the same process, which is that the window unit actually articulates. It goes from that U shape and it pivots up. One side pivots up to become an L, like the bracket. And that's the outside part. And then you take two people, pick it up and slide it in. And then there's a little hydraulic mechanism on the bracket that enables that outside portion to come down flat so that you're back into your U shape. So, and then it's as simple as plugging it in. And of course, there's all the sealing around the window. They come with a pretty elaborate kit for that. There's probably as much time or more working on that part than there is actually getting the unit into place. So that is pretty much it. I think actually in the next slide, there are some pictures of the installation process. It's hard to see in these pictures, but if you look at that middle one, you can kind of get a sense of the fact that that's articulated up and they're just sliding it straight out. So you're not trying to like muscle it up and over kind of as a U. You're sliding it out, so you don't have to lift it up off the ground very high.
Do you know on average how much these weigh?
Yeah, so they're not light. So the units that are going in here are 125 pounds.
Oh my.
So they're no joke. And this is why when I sort of have an asterisk on the DIY part of this, they may or may not be realistic. At the very least, we're definitely talking about two able-bodied people to be able to put these things in. This is not a single person installation.
Gotcha. Yeah, thank you. Another question about, I think you said you'll get to condensate management. Is that coming up?
I was gonna sort of leave it there, but I will I will I can happily answer that now. So there are different strategies that are being used. And I think so one of them has a little vessel that collects the condensate. So there's a little container that all of that liquid goes into. And then from there, there's a pump mechanism, which actually pumps that liquid, that water, into a atomizing nozzle that's aimed to the exterior. And so essentially what it does is it mists all of that water out and essentially turns into snow before it hits the ground if it's freezing outside, or effectively sort of dissipates if it's not that cold out. So that's the way one of them are doing it. The other, I believe, has a system for it's reversed. So they're monitoring the indoor humidity, and then you can actually set your indoor humidity, optimized humidity. So, of course, in the wintertime when you're running these, a lot of people are also running humidifiers. So you can say, I want to set a 50% humidity level, and it will kind of do a similar process, but to the interior. And then when it hits the humidity set point, it starts to fling. There's a traditional, I forget, I think they call it a flinger or slinger. That's what I'm trying to say. There's a slinger in there that slings the extra condensate onto the hot condensing unit, and it just kind of goes off as steam.
Thanks for that. Um, and if you're not going to get to this later on, before we end, if you can give some details on where to find them, where they're available,
Yeah, I'll talk about that stuff at the end.
that'd be great. Thanks so much.
Okay. All right, let's get back into it. So the Clean Heat for All challenge that I've been talking about, they're wrapping up. I believe they're actually completed at this point, the demonstration phase of the project. And so they've installed 36 of each of the different manufactured units, and they've put these into these apartments in New York City. You can see on that picture on the right, kind of a bunch of these things stacked. Actually, now that I'm looking at it, there is in that picture all the way on the right, you can see that one of them is being installed because it's still sticking straight out. It hasn't actually swung all the way down yet. So the units that are sort of down below it, you can see they're fully installed. And that one at the very top on the right is sort of sticking straight out. That's in process of being installed. So these are going in. They did this using the property management that manages these buildings in New York City. And apparently the report came back that it was really straightforward, very smooth. I think these guys did, I want to say 8 a day. A pair of 2 guys did 8 of them a day. So it worked out pretty well. They got those done, I think, in a week or so. And they've done quite a bit of metering there using, temperature meters and E-gauge power meters. And so there's a big evaluation that's taking place to evaluate the performance of the equipment. The last I heard on that, and we haven't been directly involved, but I am in communication with the folks that are doing this work. And so far, generally speaking, actually have had really, really excellent performance. They have disabled the gas system, the gas heating system in this whole wing of the building. So there is no gas heat, and they've now been through a full winter with this equipment. And I believe the report back from all of the tenants is that they really enjoy using this. They're much more comfortable than they were before. For those of you that have any experience in New York City public housing, there's a lot of very old systems, a lot of steam, and a lot of overheating, lack of control, people often having to open windows to, manage temperature. So this, I think, has been huge improvement in comfort for folks. Okay, so bringing this back to now to Vermont, right? We've been talking pretty exclusively about New York and their perspective on this. So in Vermont, it says this summer, we're launching a pilot actually this fall. So we won't be capturing the summertime operation. Things did get delayed a little bit, but we are focusing in on a similar type of population. So we're as I mentioned in the title of this presentation, that we're focused on renters, right? This is a solution that's pretty unique, that can help others beside renters, but it opens the door to a third of our population that we have not been able to work with and to help. So this is where we want to start our process rather than kind of getting to them at the end. We want to start there. So we're focused on lower to moderate income, preferably multifamily renters. We're going to be starting with 15 units, but with targeting 30 eventually. A little bit different. Oh, I didn't mention this earlier, and I probably should have. So in New York, the goal of this was 100% electrification. They put 3 of these window units in every apartment. It was 1 in the living space and 1 in each of the 2 bedrooms. These are all 2-bedroom units. They're all identical. In Vermont, to start, we just want to see how people use these in conjunction with an existing heating system. So we're only going to be providing 1 of these units to each renter. And we're going to be asking them to use it for heating and for cooling. And we're going to be doing a little bit of metering. But I think the main thing that we're looking at, I think we're confident now in the performance of the equipment. But one thing that we are looking to test that New York did not test is whether or not this is realistic to actually think of as a DIY. So the way we're structuring this is that these products are going to be drop shipped to participating renter apartments. They're going to have to get these things into their apartment, unbox them, read their instructions, invite their brother-in-law over or however else it's going to work, and do the installation themselves. And we are going to be sort of following them and we won't be physically there, but we will be interviewing them after that experience to see how it went, right? So we don't know. The manufacturers are also very curious, right? They would love to be able to market these things as DIY products, but it's unclear whether or not that's actually a realistic expectation. So one of the major things we're looking at. So these are not commercially available yet. And I know that's going to be a question that comes up. In fact, to the best of my knowledge, aside from New York City, this is the second place in really anywhere that these new units, these Clean Heat for All Challenge units, are going to be installed. So we are partnering with the manufacturers. They're really excited about this as well. That said, and I do have a slide about the commercial viability, so I'll address that in a moment. So I don't want to just be all rosy here, right? There are some real challenges that I want to, call out. So first of all, these only work in hung windows, right? Single or double hung vertical sliders. That's the only way that these can be installed. If you have a casement or an awning or even traditional horizontal sliders, these will not go into those windows. So that is definitely going to limit the opportunity. That said, of course, I think we all know that hung windows are probably the predominant window type that we have, especially in Vermont. So I think it's still a good opportunity, but it's not going to be a solution for everyone. I mentioned the limited capacity range. That's definitely a concern, maybe not so much for living space, which is where we're going to be testing these, but for putting these into bedrooms, 9,000 BTUs is going to be overkill for most buildings, right? Most bedrooms are going to need half to a third of that capacity. So and 9,000 may not be enough for some bigger living spaces. So I do know that the manufacturers are already working on alternative sizes and increasing the range, right? This is super new. So they're just trying to get their products out there for now, but I think we're going to see more of this coming along. I mentioned the DIY piece, right? This is a big question mark and really the primary thing that we're going to be testing. Cost is also something that I know is on everyone's mind, right? Like if we're going to reach all of these, especially low and moderate income, that we need these things to be a very low cost. They're right around they're anticipating them being around a $3,000 price tag, which I think is going to put them out of reach for a lot of people. Now, that is really, there's a couple of things that I want to address there, but I will say that for one, this is just the initial rollout, right? And we often see that these things will come down, especially at the increase in the scale of product that they're getting out there. Do anticipate seeing these come down in cost. They do include some things that were very specific to the New York Clean Heat for All Challenge that probably would not be in a product developed for like the commercial market. Just as an example, they have backnet compatibility that was very specific to the New York public housing. They want to control these through a building management system. 99.9% of our buildings are not going to need something like that. So that would help reduce costs. So there's a lot of things I think that we could anticipate seeing costs come down. Of course, as with any window AC type units, some like housing groups like condos do not allow those to go in. So that's something that will need to be addressed. For now, in terms of cold climate, there's just really those two products. Those are the only products, but we do anticipate, again, seeing quite a bit more coming down. I know at least one, if not two or three manufacturers that are adding this product to their product line. And someone's going to ask about ventilation. These do not, at this point in time, they do not provide ventilation. There are kind of similar type products out there that do integrate ventilation, even with heat recovery, but we're not seeing that, at least not yet, with this product type. So what's coming down the line here? So this is a very important stuff that I think can really help resolve a number of these issues. I'm not going to go into a ton of specific detail, but there wasn't an official testing procedure for these products. Are so new that there was no testing procedure for the heating performance. So that has been in process. And the main reason why we really need that, in addition to just informing consumer choices, was in order to enable access to these Inflation Reduction Act tax credits and other rebates. So that is huge, and it looks like we are actually now on schedule to have that all available for any installation that happens on January 1st of this coming year. And so just to give a sense of how big that is, They're, for lower income populations, in addition to a $2,000 tax credit, it's up to $8,000 in rebates for these folks. So you can imagine right there, if that's potentially up to $10,000, you could buy 3 of these things at zero cost. So that's a huge, huge opportunity that it looks like is going to be in place for Jan 1 of this coming year. And I've mentioned that there's lots of companies that are starting to talk about, think about this, and are beginning to develop products in addition to Midea and Gradient. And I know that they're all looking at creating other sizes and maybe more commercially viable units, meaning they don't have all the bells and whistles, but they still have the main kind of core of what makes these things valuable, being a cold climate heat pump. And in terms of when they're going to become available, it's hard to nail these guys down. But, my understanding is that in November, both Midea and Gradient are going to sort of like a mass production mode. So they do have to meet the needs of that Clean Heat for All challenge. They each have to supply 15,000 units for that. So that is going to suck up sort of a lot of the oxygen in terms of the manufacturing process. But I think we should definitely in 2025 start to see, potentially even in the first half of 2025, start to see some of these products available. Not the full suite of options, but it's starting to at least be able to get our hands on them. And as part of that, in addition to all of the federal stuff and all that, we at Efficiency Vermont are actually, the reason we're running this pilot is to evaluate an ongoing incentive program. So TBD on that, but do anticipate these being incorporated into our incentive programs in one way or another. And with that, I'm going to tie up my official presentation portion, but I'd love to get into a conversation, answer any questions that anyone has.
Thanks, Jake. Do you have a closing slide with any contact information on it?
I don't, but I can absolutely get that to everybody.
Okay, no worries. Thanks. We did have a question earlier asking about maintenance that's anticipated, any maintenance that requires some professionals, contractors to address it versus the resident or the occupant that may have the ability to address the maintenance need.
It's a great question. I'm not sure we know yet. In terms of anticipation, I think right now they're being thought of really as a window unit. So I don't know of anybody who's doing any kind of maintenance on their window air conditioning unit. As with any heat pump, any air source heat pump, we're going to recommend that it gets cleaned. How that works, given the fact that you have this thing hanging out of a window, do you have to take it out? I think a lot of that is really TBD. So those are questions that have been raised in the past, and I haven't heard any great answers. So we'll keep you guys updated as we learn more.
Is the evaluation from New York City, is that complete, or is that
no, it's in process right now. I don't know how public that will be, but if folks are interested, please leave your name and contact information with Brennan and myself, and I'll see what I can get my hands on that can be shared. If folks really want to get into the nitty-gritty of how the evaluation is being done.
Great. We do have time for additional questions, so if you want to raise your hand or type anything in the chat, we can get to those in a minute. We'll give you a few seconds here to think about those.
I'll also ask a question of the group, which I'm curious. So assuming we do have some contractors in the mix on this call, I'm curious what your reaction is to this technology and how you see it potentially fitting into the work that you do. Is it a threat? Is it an opportunity? I'd be curious to hear what folks' reactions are. And if you're not sure yet, feel free to follow up with me in the future. I'd love to have that conversation. I think it's I'd like to think of it as a great opportunity. I think that even though some people will be able to DIY these things, I do think that it's a little bit beyond the ability of the average person, and that I could see it being some sort of another tool in the toolbox. Not
We've got at
every
least
Yeah.
one contractor that shared that they think it provides some opportunity.
Yeah. Yeah, it's new. It's another thing to kind of add into the mix. And as you're working with customers and understanding what their needs are, another tool in the toolbox, so to speak. So yeah, I think the anticipation, at least from the manufacturers that I've spoken with thus far, is they're really not, at least initially, they are not interested in rolling this out as like a direct to consumer DIY type thing. They're looking at more of like a distribution channel. So I think they're on the same line of thinking, is that there may be a future opportunity to sell these like at home supplies, at home goods stores like Home Depot, but that's really not what they're targeting, at least not initially. They're thinking that this is maybe a contractor installed product. It could be a general contractor. It doesn't even necessarily have to be like an HVAC contractor, but they're definitely looking at more like a contractor installed product.
Do you have a sense? It sounds like in the New York City pilot, they were using these year round.
Yes.
Do you anticipate the climate in Vermont being similar enough to New York City for year round use?
Sorry, what was the last part of that? Being
Do
similar
you
enough?
anticipate the climate in northern Vermont to be similar enough to southern New England for year round use?
Oh, absolutely. Yeah. Now, again, they were designed, these are definitely designed for year-round use in Vermont, no question. Now, whether or not they're going to meet the needs to be 100%, tear out your fossil fuel heating system is still a little bit TBD. I think we're sort of in the same place with ductless heat pumps or even ducted heat pumps that, yes, absolutely. In the right buildings, we see this done all the time. Is that an option for every building? Maybe, maybe not. I know this is always a sensitive topic. It seems that people have strong feelings one way or another. I think any building can be run 100% on heat pumps. But it may need some weatherization. It may need a lot of heat pumps. So, but yeah, these are designed to operate down well into the negative numbers. So other than just some very, very outlying polar vortex -25 for multiple days, which I haven't seen in a long time. Yes, it's gonna do what we need to do.
Hopefully we don't get one this year now that you jinxed us. So
Yeah.
one other comment from a contractor about opportunity versus threat. They say that they want to see one installed and see how it works. It's a little
Me
too
too.
soon to tell. It may be good in some instances, but mini split likely is better in other cases. So kind of use dependent.
Yeah, I 100% agree. I don't by any means see this as a replacement for the ductless mini split. I don't think My hope is that this is purely additive and not a replacement. I think that the having a ductless mini split that's up and away is going to still be a highly preferred option for many, many situations. But I do think that there are, especially when, based on that long list of things that I put in there, for renters in particular, it can be a real challenge to do traditional heat pumps. And so, um, yeah, I think that use case alone potentially opens the door to 30% more customers that we have just not had access to, generally speaking, in the past.
Great. Thanks for that. Any more questions coming in? Feel free to put them in the chat, anything that comes to mind. It's a great opportunity to pick Jake's brain on this, see what's happening else, in our neighboring states as well as nationally, with some of this new innovative technology. We're excited to have you offer this presentation again as a webinar as well. So thank you for that. You had on a slide, 1 or 2 slides ago, what the anticipated rollout timeline is. If you could just, yeah, there you go. If you could go back to that.
Yep. So as I mentioned, it's hard to nail down these manufacturers. Like, when can I buy this thing? Everybody asks them that question, and they never really want to commit. But I do know that in November of this year, at least my idea is moving to full-scale production. So they're moving into their full line of production, out of the R&D prototype type space and into full production. Now, what that translates to in terms of when can I go buy it is still a little bit TBD. But I think by the sometime in the first half of next year, preferably the first quarter, but maybe through, I would say, by next summer, we should absolutely be seeing these things available. So
Great. And a question came in. Did you happen to cover any SEER or HSPF values?
I did not. They're not using those metrics. Apparently, when they were developing the testing standards, there's something about the way they test the equipment that they had to come up with something new. So they're using, I believe it's called HEER, HEER, the heating energy efficiency ratio. So of course, that's not that meaningful to any of us. My understanding is that when you sort of look at sort of translating it to what we're accustomed to seeing, like SEER and HSPF, these are more or less on par with the best-in-class ductless mini splits that we see out there. So they're very high performing, maybe not as good as the best, but they're definitely middle to upper in terms of performance.
And then do you anticipate, it sounded like at the beginning, you anticipated these to be covered by IRA to meet IRA requirements?
Yes. Yeah. So it's sort of a complex web, but it does look like all of the parts and pieces are going to be in place for that to be available for every purchase that happens on Jan 1 of 2025 or after.
Great. So IRA, sorry, is Inflation Reduction Act. And with these systems, they wouldn't need to do load calculations. Is that right?
That's a complicated question. I am not sure. It depends on the program that we're sort of dialing into. What Bryn is referring to is the fact that there are programs under the IRA that are going to require any subsidization of heat pumps has to meet greater than 50% of the building's heating load. So I'm not certain where this product is going to plug into sort of the suite of initiatives that are going to be available. I know, for example, that the tax credit piece, the $2,000 tax credit is separate from that and is not dependent on that. So that will be, this is what was referred to as 25C for those IRA tax geeks amongst us. So this is under the 25C tax credit piece. That's ductless mini splits are in there. These will be in there starting on Jan 1 for sure. Now, when it comes to the rest, the other sort of 8,000 for lower income populations, that's where it gets a little bit messy because it's being done on a state by state basis. And so I'm not certain how that's going to kind of roll out in Vermont yet. That's all in the works.
Great, thank you. We had a good question come in about noise and how it compares to a regular window AC or hotel through wall units.
Yeah. So these are inverter driven, high quality, all the same types of components that you would see in like a higher end ductless mini split. So these are extremely quiet, whisper quiet. I've heard them when they're on, you can barely tell that they're running. And the feedback from the people that are living with these things is that they love them. They are heating and cooling as they're designed, and you can barely even tell that they're running. So very low vibration. So we're gonna not be able to call them window shakers anymore because they don't actually shake windows. So, and because again, they are inverter driven, they're going to be operating most of the time at a very, very, very low speed. So maybe when it's, a super, super cold day and it's at its highest, but it's still the decibel ratings. I don't know what they are off the top of my head, but they're very low. So I've seen them running because again, you can just plug them in. So I've seen these things at trade shows where they just plug them in and you have to literally go up to it and put your ear against the thing. Is it on? So you can feel it blowing, but they're very quiet.
Great, that's awesome. Very exciting news there. Well,